Hi 11, this is Mr. Sayer. So this is a video on 4D. So this is the absolute value function. So question 1, H. So absolute value of 11 minus 16, take away 8. So, usual BODMAS rule still applies. So whatever you do inside the bracket, so bracket being here in this case the absolute value, so you have to do this part first. So that'll be absolute of negative 5, and that's going to be 5, and take away 8, which will give you minus 3. Okay, so that's these two. All right, so and then negative 8 later on. All right, question 2. So part B, solve this absolute value equation. So absolute value of x is 3. So inside, you got two possibilities. It could be plus and minus 3. So, because the absolute value of negative 3 is still 3. So you got two possibilities. So hence on the number line, it'll be the 3 and negative 3. So it got two dots there. Part E, absolute 2x equals 6. Same sort of thing going on. So instead, in this case, you have to treat the 2x as if it's a single prenumeral. So it's 2x. All right, so then 2x is plus and minus 6, hence dividing both sides by 2, you get x equals plus minus 3. Or you could think of it this way, absolute 2x, so you can take the 2 out because it's a positive number, so you can move the 2 outside the absolute value. So that's the same thing as saying 2 times the absolute x equals 6, divide both sides by 2, then you get absolute x equals 3, hence x equals plus minus 3. You get the same answer, and coincidentally it happens to be the same answer as in B, so same number line. Question 3, B. So with this one here, you've got two terms, but same sort of deal going on. X, you have to treat the x minus 3, whatever that's inside the absolute value, as a single term. So that means this x minus 3 has two choices, and that is plus and minus 7. Hence, you need to now go ahead and solve these two equations. So first case is 3, so it's negative 3, tossed over to the other side becomes positive 3. So just exactly the same, behaves the same way that you would solve for an equation. So 3 and then plus or minus 7. What that means is the first case is 3 plus 7, and the second case is 3 take away 7. So that it's 10 and negative 4. Hence on the number line, it's the 10 and negative 4, like that. Part F, x plus 2. Again, you got two terms inside the absolute value. So you got two scenarios, that's being plus 2, and the other one is negative 2. So move that 2 over to the other side, becomes negative 2, and plus and minus 2. So that and that, and gives you 0 and negative 4 respectively. Hence the answers are 0 there and negative 4. So the two dots on the number line. All right, question 5. This is a true or false question. Question 5 is you have to prove that every single question in question 5 are true. So you have to show that the left-hand side equals to the right-hand side. Left-hand side equals to the right-hand side. So let's take a look. The left-hand side is this. So you have to start from that one. It's a negative x, x being negative 3. So it's a negative of negative 3, all within the absolute value sign. So it's a negative, negative, positive. But absolute value of 3 is still 3, so that's the left-hand side. Right-hand side is the absolute value of negative 3. By definition, that just spits out the absolute value, the positive value of that, which is 3. So these 3 and that is 3 the same, hence left-hand side equals the right-hand side. Therefore, it's a true statement. Part E, x is less than or equal to absolute x, where x being negative 3. Again, the left-hand side is just x, which is minus 3. Right-hand side, which is the absolute x, which is the absolute of negative 3, is 3. And we know that the positive is bigger than the negative. So that's that one. Hence, the inequality sign satisfies the relationship. Hence, that is a true statement. All right. Page 2. So question that I've chosen to do is question 6. All right, this time it's all false, so you have to prove that they're all false where x is -2. Okay, so left-hand side is negative absolute of negative x, so absolute negative of -2, that's going to be +2, which is 2, but the right-hand side is just -2, and obviously 2 and -2 aren't the same, hence this statement is false. Part E, you have to prove that this inequality is false, so left-hand side is the absolute x minus 1, x being -2, take away 1 is absolute -3, but that is just 3. Right-hand side though, absolute -2 take away 1. Well, absolute -2 is just 2, okay? So that one is just that, okay? Hence 2 take away is 1, and as you can see, 3 is actually bigger than 1, okay? In other words, left-hand side is bigger than 1, but it's originally saying left-hand side is less than the right-hand side. So that's not true, hence that's false. Question 7. So this time it's now, again, that's the equation question. So 2x plus 1, you have to think of that whole thing as a single term because they're all sitting inside the same absolute value. So 2x plus 1 is equal to plus or minus 3. Hence, now move that one over to the other side, becomes -1. Hence, -1 plus 3 and -1, -3. So that's going to be 2, and that's going to give you -4, but you still have 2 in front. So divide everything by 2 to get 1 and -2. So these are the two answers. Now, to check, it's always a good habit to check. So now sub back in. So 1 back into that equation. So 2 times 1 plus 1 is absolute 3, which is 3, which is the right-hand side. So it satisfies. The second solution, -2, put it in there. You get -4 plus 1, which is -3, but sitting inside the absolute value. So that's going to be 3 again. So both satisfies the equation. Part E, now this absolute value is equal to -8. Now, you don't even have to go any further because we know by definition that the absolute value has to be always greater than or equal to 0. But that is less than 0. Hence, we know that without even further solving this, there is no solution to satisfy this. Okay. All right. Question 9. All right. So this is, what do I have to do? Okay, yeah, you have to now sketch this. All right, so think of this as, remember when we did the transformations, y equals f of x plus 2. So what that meant was you have to move the y equals f of x by -2 or 2 units to the left because you have to look for the x value that makes this thing 0, which is x equals -2. So that's exactly the same argument. So you can think of the absolute value as a pair of brackets. So you think of the x value that makes this whole thing 0, which is -2. X is -2. So it's the x. So you have, because it's the x, it's the movement along the x-axis or horizontal movement. So, and it's -2, so that's 2 units. So 2 units to the left. So hence, draw the original y equals absolute x, which is the perfect V shape touching the origin. And now you move that one by 2 units to the left. So then you get that. Okay. So then you'll see that the x-intercept is now -2 and the y-intercept is 2. Again, to get the y-intercept, you put x equals 0. That's going to be absolute value of 2, which is 2. Okay. Righto. So question now 9b. All right. So this time y equals absolute x, take away 2. You can rewrite that as moving that one over to the other side and y plus 2 equals x. So hence it's the y value that makes the left-hand side 0, which is that. So y equals -2. Hence it's y. So it's the movement along the y-axis. And it's the negative, so it's down by 2 units. So down by 2 units. So that's the original y equals absolute x curve. And you move that one and drag this curve by 2 units down. Then you get this, which is y equals absolute x minus 2. Okay. Part 4, sorry, 6, y equals absolute x plus 1, take away 1. Again, you shift that one over to the other side, and you get this. So look for the y value that makes the left-hand side 0, and you look for the x value that makes the stuff inside the absolute value 0. So respectively, then you get y equals -1, x equals -1. Hence, it's down by 1 unit, and that means left by 1 unit. You move to the left by 1 unit. So draw the original y equals absolute x. So left 1 unit and down 1 unit. Then you get this. So the new, if you like, the vertex is going to be -1, -1, and that's that one. And notice this light ray here is exactly the same as this part of the light ray, if you like, okay? Because they still maintain the 45 degree, okay? Because it's both of these cases, whether it's this or that, the gradient of it is still as 1, okay? So that's why it's exactly the same line. Okay, next page, if I can flip it. Question 11. All right, so y equals b, so y equals absolute 9 minus 3x. Now, notice it doesn't give you the explanation. It doesn't require you to explain this with respect to y equals absolute 3x. Now, this is a generic curve of the absolute value where you have to generate it from scratch. So the way to go about it is draw the original linear function like that without the absolute value. So y equals 9 minus 3x. Then you get this, okay? Now, you should really be up to scratch as far as this drawing the straight line goes, finding the x-intercept and the y-intercept and all that. And I still gave you the explanation as to how to find the x-intercept. Y-intercept is easy, that's the constant term there, that's going to be the y-intercept. Now, next part, to draw this absolute value function, what you need to do is, like I said here, you only focus on the part that is under the x-axis. So that's the part where all the y values are less than 0. So all the dotted line that I've indicated. And because it's the absolute value, what do you know about the absolute value? This is always greater than or equal to 0 by definition. So what that means is grab the part that is under the x-axis and flip it about the x-axis. That by the arrow, that arrow there is what I mean by rotation about the axis. So this part stays the same because that's already above the x-axis. The part that is under the x-axis from the original straight line, to get the absolute value function of it is to grab that and rotate it. Then you get this nice V curve, which is the absolute value function. So that's how you generate it from scratch. Okay. All right. So now the next part, same sort of question. Sketch both, this time the absolute value function and then the horizontal line function. So to do this, yes, you can draw y equals absolute x and then you move it by 4 units to the right this time, okay? But let's suppose we're trying to generate it from scratch. So in other words, from y equals x minus 4 function, the straight line, then you get this, okay? So that's -4 is the y-intercept and 4 is the x-intercept. And what did I say? Once you've got that, you focus on the part that is under the x-axis, which is that dotted line there, okay? And what do I do with this? Grab this end and rotate it or flip it about the x-axis to get this, okay? Remember, that's -4. So now once you've flipped it about the x-axis, it's going to be now +4. So that's why you get that. And y equals 1 is this one here. It's a quarter way through to the 4 because it's 4 and a quarter of it is 1. So as you can see then, to make intersection occurs at those 2 points, okay? Now, then what are the coordinates for this and that, okay? Or at least the x coordinate for that intersection point and x coordinate for that second intersection point. Well, you can now solve this absolute value equation like we did before. So again, you have to treat the x minus 4 there as a single term. So that means x minus 4 has to be plus and minus 1. Okay, hence x equals 4, because you have to move the negative 4 over to the other side. So that's 4 plus and minus 1, hence it's going to be 5 and 3. That means the less one, so that one there, less than 4 has to be 3, and bigger than 4, x2, has to be 5. So that's that. Okay. All right, so that about does it for this video, and make sure you now have a go at those questions that I've listed. So I'll see you guys next time.